Welcome to the NGI Zero podcast, where we talk to the people who are building the next generation internet.
I am Ronny.
And I am Tessel Renzenbrink. We're both from NLnet, a foundation which supports people who are working on a free and open internet. Our guest today is Janneke. He is a physicist, the co-founder of GNU Lillipond, co-founder of Do 040, the democratic school in Eindhoven, a Guix developer and founder of GNU Mes. The GNU Mes project received several NGI Zero grants, and that's what we'll be talking about today. Hi Janneke, nice to have you here.
Yeah, great to be here. Thanks for having me.
Okay, we have devised 3 short questions that would let our listeners know everything about you if you have answered them. So,
Everything.
So here we go. Emacs or Vim?
Emacs.
Star Trek or Star Wars?
Wow, that's a difficult one. In my youth, Star Trek. Now definitely Star Wars.
And the final one. There is life outside our solar system. We are alone.
There's life outside our solar system. Yeah.
Agreed.
So, you work on operating systems. What key issues do you see in this field?
Yeah, that's a good question. When you say I work on operating systems, I was going, am I doing that? So, in my mind, I'm working on problems that I see in the world, especially when I think there's an elegant solution for the thing. So I got involved in GNU Guix, sort of by chance, because I love Scheme. I think the world would be a better place if people started using functional programming more, because that's a real help. So I got into Guix because I started to use Guile more in my programming, and I love the idea of the idea behind Guix. Guix is of course implementing the Nix thesis, which for me boils down to the fact of the observation that a traditional package management is actually a broken system. If you're lucky, it works, and if you put in a lot of hard work, you can get it to almost always work. But in essence, what you want for a package manager is to describe all the dependencies that a program has. That is what Nix does, and that is what Guix does. So I love an elegant solution for a problem that people are ignoring.
Okay, so that's you describing what you think is important, and then how does GNU Mes add to that? How does it contribute?
Yeah, so when I started working on Guix, I started reading a manual. Especially Ludovic Cortés did a great job of writing a beautiful manual. But somewhere in the manual, he explains how the packages in Guix are an acyclic directed graph, their dependencies, and that in Guix, the same goes for Nix, by the way. If you install or build a package, what you do is philosophically, you build it from source together with all its dependencies. And that goes for every package except for the bootstrap binaries. And in the manual, I read the text of Ludovic, where he said, well, that last thing, the bootstrap binaries, we can rebuild them, of course, but they are not built from source. And that is a problem, because they are opaque and they're pretty large, and they cannot be inspected. So at the same time, when I joined Guix around 2016 was that, there was another project by Jeremiah Orians, the Stage Zero project, where he built a self-hosting hex assembler program in a couple of hundred bytes, I think 357 at the time. And I combined those two things. So the problem we have in Guix that we trust binaries that we don't build from source, and the inspiration of a 200 or 300 byte program that can build itself. And my idea was Mes can bridge the gap between a simple assembly language, and bring it up to Scheme, to a high-level programming language, and from there we can probably bootstrap the whole system. So that's how I started with that. So what Mes tries to do, is to make software bootstrappable, or the Guix system bootstrappable.
So you said you had a binary blob of 250, 300 megabytes or something, you said, and you have put it down to?
No. So the program by Jeremiah Orions was 357 bytes. So really small, less than a K, 1K. Okay. And that program can build itself. So that's really on the small kind of range of the spectrum. And on the other range of the spectrum was the bootstrap binaries that we have in Guix. Those were 250 megabytes. The traditional distributions use a much larger binary seed, often twice as large, so half a gigabyte of opaque binaries. And using Guix, yes, we brought that down from 250 megabytes to, well, depends on how you're counting. The upper limit is 20 megabytes, so a factor of 10, an order smaller, because we still depend on stuff, of course. But we build everything from source, starting from this couple of hundred bytes currently if you install Guix.
Wow, that's amazing.
I think so too. I never thought we would achieve this in so little time.
And this 357 bytes, they are assembly?
Jeremiah calls it an hex assembler. So it's a custom assembler, and actually that is written in machine code. So it's architecture dependent. So for every architecture, there's another a binary, and it's a real simple language. It's simply you enter the bytes, but then an ASCII. So if you want to, so you're actually writing machine code. So you write the instructions, the opcodes and the operands in simply in numbers. But there's also a comment a comment character, which is a pound sign, and after that you manually write which instruction is going to be what the instruction actually is. So you write machine code, but in that machine code, that program, the Hex Zero program, can interpret its ASCII variant and produce a running executable from itself. So it's self-hosting.
Can you take us along a bit and you look at the very beginning, you look at 250 megabytes. What kind of steps did you do to reduce it like this?
Yes, so the 250 megabytes is I first start looking what's in there, of course. So it's the usual suspects. It's GCC, it's glibc, it's binutils, stuff like awk and sed and core utils, and tar and gzip, stuff like that. So I figured what we really need to remove there is GCC, glibc and binutils. So I started focusing on that. So after I got Mes a bit started, and it was able to compile a trivial C program. I asked around on the Guile user mailing list, can somebody help me with this? I have this idea. I'd like to build a C compiler in Scheme so that the idea was that we could build GCC, glibc, and binutils without using GCC, glibc, and binutils. So that was the initial idea. So replace GCC by a smaller C compiler binary.
That was step one.
That was step one. So Mes is a Scheme interpreter. And I just replaced the GCC binary in our Bootstrap binaries by the Mes binary. But it's a lot smaller than, it's 2 orders of magnitude smaller than GCC. That's the first thing that I did. And I wrote a C compiler in Scheme. And I was wondering if I could compile GCC maybe with that C compiler, but it's terribly slow, and the CCC source code, even if you look at GCC 1.0, uses pretty funky C. So yeah, so we found another smaller C compiler project, which is TinyCC, and TinyCC has an explicit target or goal for what they do is to be able to compile GCC. And TinyCC is 4 times smaller than GCC 1, so only 20 to 25,000 lines of C code. And it doesn't use many funky C construct. It's relatively simple C. So I focused on that. And yeah, so the first real milestone was when I was able to compile a working TinyCC using Mes.
And does GNU Mes only work for GNU Guix?
At the moment, sadly, that is the case. So there's no inherent limitation. As I write in my blob or blurb of Mes, I'd like Mes to help bootstrapping all free Linuxes or free Unix distributions even. But so far, only Guix has adopted the Mes bootstrap path.
Could NixOS, for example, be the next one?
Yeah, I'm hoping. So about a year ago, I think, there's been an effort by Emily, and I forgot her last name, Emily Troe, who actually got, I think, 1 or 2 PRs into Nix to build Mes, to bootstrap Mes using stage 0. So it's already a much more mature path than what I just described. But as far as I know, the effort of working on a full bootstrap into Nix is currently stalled. So we talked about this also at FOSDEM this year to see if we can somehow nudge some Nix developers to help Emily get an NLnet grant and bring this to Nix because this really should be the next step, I believe. Yeah.
Yeah, great. And maybe for people that maybe may not understand the importance of this, what is the importance of being able to bootstrap the whole operating system?
Yeah, I think it's very easy to underestimate the importance of it. I would like to ask the question, we all love free software, and it's if you ask the question, why is it important to use free software? Well, of course, I want to have control over my machine, privacy, being autonomous, that kind of thing, being able to create a community and build things together. But can you really speak of a program being free software if you cannot bootstrap it? That would be my question. I would argue, but I know that I had plenty of discussions and people disagree with me, but there are also people who agree. I would say that if you have a free software program that cannot be bootstrapped, that it's not free software. So for me, it would be essential to free software.
So if you cannot inspect the code from the ground up, you cannot trust the operating system.
Yeah, so it boils down to Ken Thompson's Trusting Trust paper, where he shows that if somehow something in your stack, for example, your C compiler, is tainted or compromised, your whole system, you cannot trust anything of your system. You have to trust initial binaries. So you always have to trust something. There's the hardware and there's other stuff, and you cannot inspect all source code by yourself. But I think it makes sense to reduce the amount of trust that you need as much as possible.
Yeah, indeed, yes, and this is a great step towards that.
So I would, thank you. So I've been playing with the idea. I haven't announced it yet, and maybe it's just to stir things up. But I was thinking about the idea that we have the 4 software freedoms as published by the FSF. That we might need a 5th freedom, freedom 4, the freedom to bootstrap the program and recreate it bit for bit. So if a binary is available and you can't build it totally from source, how would you ever exercise freedom 0 to run it as you wish?
Yeah, and I think adding to that, another important thing is if you want to have through freedom, you want to run this on open hardware.
Yeah.
And so that the hardware can also be inspected, at least during build time.
That's why I'm so happy with the effort of Ekaid Saraga and Andreas Stikonas, who've been working for a couple of years now, I think, very hard, and thankfully sponsored by NLnet too, on bringing this bootstrap to RISC-V, which could be a big boost for the bootstrap too.
Yep, indeed. Yeah. So what are the next steps for the project?
Yeah, I've been thinking about that. And in a way, it's I've been doing this for 8 years now, and it's always been pretty obvious what the next logical step would be. And since 1.5 years, we now have this bootstrap in Guix. My idea was, and my hope was, that when we would show that it would be possible to do, because I've talked to a big sigh. I've talked to a lot of naysayers the past decade. This cannot be done, and if you can do it, why bother? That kind of thing. I think it's fun, and it's essential, and it can be done. So I figured when more people learn about this, they would join, and most work would be taken off of my hands, so to speak. And of course, we have a technical roadmap. So currently, the Bootstrap uses an ancient version of GCC 2.95, which isn't a big problem, but because it works, but it only works for 32-bit x86. So that's where the RISC-V effort comes in. So we need to get rid of GCC or ancient software, but especially GCC 2. And there are other things in the Bootstrap that we want to clean up. Currently, we still use some implementation of core utils in the Bootstrap. We run them. We have a scheme implementation, which is called Gash with its Gash utils, which we run on the Guile driver of Guix. That path cannot be used by a Nix, of course, because they have no Guile binary. So we have to get rid of that thing. We are pretty far there, but that has to be done. Those are the biggest two technical challenges. But far more important is to grow the adoption. Like we talked about before, it would be amazing if it got into Nix, because that community is, I think it's 10 times as large, if not bigger, than Guix. It would be great to have this in Debian. Yeah, to summarize, the next step for me is not so much technical, but much more inspirational, seeing getting other communities involved in the importance of bootstrapping. For example, the people who built glibc and GCC, or people who build a kernel and decide to add Rust to it. I would love for them to learn about bootstrapping, to realize how important it is, and to take responsibility for their software to remain or become fully bootstrappable. Because to be honest, we showed that it can be done for a current system that depends on C, but the world goes very fast and everything is Rustified, and the bootstrapping community is just too small and will probably always be too small to carry this burden of making softwares that have become bootstrappable again. It would be great if it would become a no-brainer for free software. So if anyone has ideas how to best do that, I'm all ears.
Not off the top of my head, if I'm honest. Can you tell us something about the community behind GNU Mes and the bootstrappable people?
Yeah, so it's a very friendly community. I started this effort in 2016, just mailing to the Guile mailing list and the Guile user mailing list. And Ludovic Cortés has been one of my first supporters, which maybe isn't so surprising, because he wrote in his manual about Guix how important bootstrapping is. But it's been very important to have, and from other people in the Guile community also, they didn't really help with the technical work, but they cheered me on in the beginning and said, yay, go for this, this is great. So that was really great. And Ricardo Wormes, also a Guix developer, took it upon him to create a bootstrappable IRC channel. And initially we were, I think the first year we were with 5 or 10 people on there, and it's grown to 100 plus, 120 maybe, even people who are working on bootstrap relating things or cheering and so on. So that's the online community, how it started. So Jeremiah Orions was in the beginning a big help. We helped each other and coached each other through our problems. And what was also really great was the reproducible builds community. I went to the reproducible build summits in 2017 and 18 and 19. The first two were in the Berlin. And we got a podium there within the reproducible builds community to start a bootstrappable subgroup. And that a lot of great ideas came from there. So the first things I actually used was Matt Wette's ENIAC or NIAC C parser. So he wrote a parser for C for Guile scheme. And he helped a bit to make it fit for Mes. So Mes is using Matt Wette's ENIAC to parse C programs, such as TinyCC. There wasn't a lot of cooperation in the sense that I wrote a few patches and he wrote some things, I think, for Mes. but mostly worked on us on our own projects, same as Jeremiah Orions, but we made it fit together, and that was really great. And of course, after some time, Jeremiah proposed to write M2 Planet, which is a bootstrappable sub-C compiler. So it is a subset of C. Some people say I cannot call it C because it breaks some C rules. But it is when Jeremiah did that, it allowed me to dumb down the Mes C code base even further, so that we could align our two projects to work together. So I've worked a lot with Jeremiah, which was a big help. And the past years, more people joined. There's the Live Bootstrap project, which implements a bootstrap outside of any distribution, just as a reference implementation. But the community has been really great, especially the last year with Ekites and Andreas, where we talk on IRC about all our problems, and people just listen and rubber duck you and help you with the problems, sometimes even debug it. So it's I guess it helps that it was a small community, and that we achieved what we set out to do. So it's very friendly, and it's been, without that, I surely would have given up. Yeah.
And just curious, like what do you like most about the project? I mean, there's got to be something about you to look at a big blob and go like, I'm gonna spend years to just pull it apart.
I think it's a very easy project to love from my perspective. So it's a glaring problem that we have known about since the beginning of the 80s, 83 or 84, I think, that practically everybody in computing knows about, and that everybody has been ignoring, and that most people agree who look into it that it really is a big problem, and it hasn't been solved. So and then, especially when we started, there were a lot of people who said it can be done. So if you have a big problem and people say it can't be done, and someone famous wrote an article about it 40 years ago, and it involves writing your software without many dependencies like we did in the old days. So when I started Mes, it depended on nothing except for the Linux kernel, so to say. So no frameworks, no full stack developer nonsense, no JavaScript stuff, just small programs that you can understand, write yourself, and don't depend on much. It's an amazing mix, I would say.
Going back to trusting the trust problem, like Thompson described, I mean, shouldn't everything be bootstrapped in your vision?
Yes, I think everything should be bootstrapped. Yeah, but why do you ask? What do you what are you thinking about? Do you doubt that for certain things?
Well, it's not doubt. We are building a trustworthy internet.
Yeah.
In my perception, we can only trust things if we can trust what is at the base of those things. And I think, well, I'm answering my question myself a little bit maybe. If we can bootstrap certain things, then we can build on those from those. The rest, of course.
Yes.
So if we can build a safe C compiler, then we can build trustworthy programs on that safe C compiler, and the same goes for Rust, of course.
Yes, but I would say if you have an application, let's say Emacs or Vim, if you build that in Guix with the trusted C compiler that you bootstrapped, I would say those programs you built, Emacs or Vim, are also bootstrapped. So in some cases, if you have a program that that's written in C, and it only depends on libraries that are written in C that can be bootstrapped themselves, then the software is also bootstrapped. So for me, one of the problems arises is when developers start adding dependency cycles to their software. Then it becomes very hard to boot, if not impossible at that time, to bootstrap it. And yeah, what do? Then you have to go inject a binary. So my idea is that there's no technical or sound reason to inject untrusted binaries in your software stack. We've shown that you can bootstrap a system. Let's get rid of all the binary blobs and all the generated code that is still used here and there.
Yeah, couldn't agree more.
And of course, it may have downsides. If you always, if you want to build everything from source, it can take a lot of time. So I could imagine that someone would create a trusted base system where everything is bootstrapped, and that system is in some way marked as trusted and hashed, and everyone can build on that, and you don't build it yourself. But yeah, that's just using a binary substitute for something that bootstrapped. So I think doing something like that just makes sense. That's essentially what Guix and Nix do when you install a package anyway.
Yeah. You mentioned NGI Zero a couple of times already in our discussion.
Yeah.
How did NGI Zero funding help your project?
Well, that's very easy. I've had a funding for at least 3 or 4. At least 4 periods, and if I hadn't had that, I wouldn't have had the time to work on this. So it would really be a hobby project, and maybe it's hard to tell, but it's been, in my eyes, essential to get this to work. Because as you said before, where do you get the inspiration, or asked before? Why do you work on this? Why is this important or fun? It is a big project, and if it drags out too long, and it's easy to lose interest maybe. So at a perfect time, when I thought it was really early stages, I was kind of I was really surprised that when I asked for funding and explained why this was important, that NLnet, NGI Zero immediately understood why it is important and wanted to fund. Also, that support, not only financially, which was very important, but also the support and the understanding and the acknowledgement that this is important that went with it, that did really wonders for my project. So I'm really grateful for this. You're doing amazing and important work.
Well, and I want to return that, because you are doing the amazing work and with a ground laying project, I think.
Yeah, thanks. So it's one of the most lovely examples of how we help each other and bring the world forward. Yeah.
If you had to give advice to people who are now considering to apply for NGI Zero funding, what would you say to them?
I would say do it. I heard from NGI Zero from Piotr Prinz at FOSDEM. I told him about my project, or maybe he already knew about it, and he said, you have to apply for NGI funding. And I said, oh no, I'm never going to do that again. For GNU Lillipond, Han-Wen and I went through a UE funding, how do you call that, application twice, I think. It wasted months of our lives, and it didn't produce anything. And yeah, it was all spare time at that time. So your project stands still for a couple of months, which is terrible, and it's not inspiring work. So I said, I'm never going to do that again. And then he said, Piotr said, it's really easy, but we have to do it now because the deadline is today at 12. And I can help you write the application. So yeah, we wrote the application, and I got funded. So my advice, we just put in between the two of us maybe 2 or 3 hours of work to make a sound proposal, because it really helps if you know what you're doing and you can explain why your project is important. But if you do, chances are pretty good that you get funded. So it's a really lightweight process, and it can help your project a lot. So if you're doing something important for the internet, for freedom or security, go check it out.
I really like the fact that you applied, between deciding to apply and applying, it was 2 hours or something. That's
yeah.
Great. We're reaching a bit the end of the questions, but I was wondering if the people who are listening now and they want to contribute to GNU Mes, or they maybe want to help get things more bootstrappable, how can they join? How can they help? What can they do?
Yeah, so what can they do? We have an IRC channel, which is #bootstrappable on LibreNet. That would be the best thing to join. There's also the bootstrappable mailing list. I would just say check out the GNU Mes website for that information. And there's also a couple of pretty nice blog posts on the Guix website about bootstrapping and reproducible builds. So you get some background in how that all works. So yeah, if you're interested, go check it out and say hi, come say hi, send an email, or join IRC. I think there's even a matrix bridge for it. Don't hesitate, and see if there's anything that you would like to do and can pick up. There's a lot of work that we still have to do.
That's a nice invitation for anybody who's interested to have a peek. So that's from our side the question. Is there anything you would still like to say?
Yeah, maybe what I would like to say is I've been thinking, how did you asked this, how did you get involved in this? And I told you I found Guix. But of course, in a past life, I worked on GNU Lillipond. And at some time, Han-Wen and I decided to work less on that and step back a bit to give other people a chance and the community to take up. And that's been lovely. But then for a couple of years, 3 or 4 years, I didn't really have a project. And that was really great because I had a lot of free time. But there was also a kind of nagging or guilty kind of feeling, shouldn't I be programming something? But a music typesetter is really great. People enjoy that software, but I was really going, well, I was looking for something important to do, something that I would enjoy, but also something, I call it a hole in the world. When you look at the world from some distance and you say, why there's a big white space here. Why doesn't someone fill it in? So in that period, I started together with others. I took the initiative for this democratic school, which was really, I think that's really important. If you're into education at all or have children, look up democratic education and sociocracy. But I didn't have the time to really go work on that full time. So that was a fun project, but others took over. And I was still going, what shall I do? And then I just happened on Guix and found this remark from Ludovic Cortés in the manual saying, I told that before, this is important to reduce this size. And then there was, at the same time, Jeremiah with his Stage Zero project. And I was going, well, that's a gap and that's a big white space or gap or hole in the world. So, I guess what I'm saying is it really helped me to stop doing what I've been doing for a couple of the years, get out of the treadmill, look back and reflect on what could give you energy and what you think is important. And some things may just work out, but you can let that go again. So I did that with the school, but it's still a very nice thing. And sometimes it, in my case, it took 3 or 4 years to find something to work on. And I'm very happy that I didn't jump on another project, but had so much time on me to be bored enough to start this. So,
and then you were completely swallowed by it. So it was good 3 years
so
off.
I was going, I'm never going to work so hard again as I did on Lily Pond. And then, here I'm at it, doing it again. So, but it's been great fun. Yeah.
That's great, Janneke. Thank you so much for building all of GNU Mes and also for talking to us and explaining why and how and all the things it took and who helped along the way. So thank you very much for talking to us.
Yeah, I'm sure I forgot some important names. The reproducible builds community was essential to get bootstrapping going, and I want to thank that whole community too, everyone who helped.